Hello, this is Scholar Strife doing some math today in geometry. We're going to be using geometric probability. So probability is the likelihood that an event will occur. Probability is equal to the number of what is considered successes, so the number of times it actually does happen, over the number of possible outcomes. So for example, what's the probability of flipping, or if you flip a coin, it landing on heads? What's the probability of landing on the heads? Well, there's only one time it's successful. It's just heads, right? There's only two sides to a coin, so you can either get heads or tails. So one of those is a success, because we're looking for the probability of it landing on the heads, and then over two possible outcomes. Geometric probability is a probability ratio that involves geometric measures such as length or area. So there would be the length part that you want over the length total. Same thing with area, like say you're shooting at a dartboard and you want it to land in this particular area. So the area that you want over the area total. If a point lies on a segment, then the probability that the point lies on a piece of that segment is the ratio of that length of the piece to the whole length, or to the length of the whole segment. So if I wanted like AC, for example, the probability of choosing a point between A and C is the length of AC over the length of the total, which would be AB. Same thing with area. If I wanted the area of the small region there, I would take the big region minus the small. Or I would take the small region over the big region if I wanted to find the probability. So let's do some examples. Find the probability that a point chosen at random on Fj lies on Gk. So we're going to do the length of Gk, which is 1, or these are counting by, no, they're counting by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're doing Gk over Fj. So this is 9 over 12. So the probability is 3/4, or 75% chance. Okay, let's do that again. Find the probability that a point chosen at random on LP lies on MN. MN is only 1, 2, 3 units long. And LP is 12. So we have 3 over 12, which is 1/4. So 25% chance of a point randomly being selected will fall on MN. Okay, a golf ball will land somewhere on a circular green. What is the probability that the ball will land in a small white circle painted on the green? So how we would do this is we would compare the area of the small, area of the small white circle over the area of the big green. Okay, area of the small is pi r squared. So they tell you the whole length there is 15 foot, so 7.5 feet for radius. And then the big is 75 divided by 2, which is 37.5. Pi divided by pi cancels, so we're just left with 7.5 squared over 1406.25, which is about 0.04. So you have a 4% chance of landing in that white circle. Hopefully this helped you out. Have a good day.